Hi and welcome back. In this video we're going to look at a couple example codes from what we covered in the last one. So I've created a new project in PyCharm, I've called it concurrency, and we're going to create a new file in here, a new Python file that I'm going to call threads. Okay, by the way, this code is available, linked at the start of the section, which is on the GitHub for this course. So let's say you've got some code that you want to run, like we saw earlier, that asks the user for something, and then some other code that does a complex calculation. Okay, we're going to have two functions. The askUser function. This is going to, get some input from the user. And then it's going to construct this greeting. And finally, it's just going to print it out, greet. This is what this function does. And as you know, this function here is going to wait for the user to type something. Okay? These functions here, or these statements here, are not going to wait for anything. We'd say that this is a blocking operation. Okay? An operation where your thread is blocked, waiting for something to happen. So these operations are what makes your threaded code slow. Okay? Don't worry about that too much. We're going to explore this concept more and more over the coming videos. Then you're also going to have a complex calculation function that is going to do something like print, started calculating, and then it's going to do something that takes a while. It's just going to do something pretty silly, x to the power of 2 for x in range 20 million. Okay, 20 million? 20 million will do. So this should take about 6 or 7 seconds in my machine. It could take longer or shorter in your machine, just tweak the number accordingly. Okay, so it's going to do that. And that's it. Then we're going to do askUser first. And then we're going to do our complex calculation. Now, of course, we're not going to know how long they take unless we start timing them. So we're going to import time at the top. And all I'm going to do is every function time it. So we're going to do start equals time.time. And at the end, we're going to print askUser time.time minus start. Okay. Same thing for the complex calculation. Now, I'm also going to do this for the whole program. So I'm going to track how long the whole program took. Like that. Okay. Again, all that's happening here is, first of all, we start a timer. Then we launch the askUser function, which starts a timer inside that function, asks the user for some input, waits for the user to type, constructs a new string and prints it out, and then it's going to print the end time. Then it's going to launch the complex calculation function, which is going to start a timer, print how you started calculating, go through this list comprehension, which is a pretty massive one. When it's done, it's going to print out that the complex calculation took a certain amount of time. And then at the very end, we're going to print that the single thread took some amount of time. You know from all the Python development we've been doing up to here that this is going to run from top to bottom. This is going to run first, and then this one, our execution is going to jump to here, then here, then here, then it's going to go back, and then it's going to go here, and so forth. This is a single thread. This is our normal Python runtime. We sort of write our code, and it runs from top to bottom because the thread is this line of execution that we've given to the CPU core to run. So if we run this file, if we run threads, the first thing it's going to do is ask me my name. I'm going to type it in. Oh, and I think I put one too few zeros here. Didn't take long enough. Notice how the complex calculation took 0.6 seconds. I want it to take 6 seconds, so I'm going to run it again. So types my name, and it took 1.6 seconds to run the askUser function, and then it started calculating. And it took about 6.4 seconds to run the complex calculation. And in total, it adds these two together essentially, plus a little bit of time, not a lot of it, but a slight amount, this single thread took 8.14. The slight amount extra it takes is because, it has to jump from here to up to the function and so forth. That takes a couple nanoseconds. So it's not going to be an exact addition. But, overall, it's sequential. First we ran this, then we ran this, and the total is more or less the addition of both. Okay. Now, what we're going to do is I'm going to collapse these functions. This does not delete them, it just hides the code in them, so it's a bit easier for you to see. They're still doing the same thing, okay? And what we're going to do then is from threading, import thread. So we're going to import the thread class from the threading module. The threading module comes with Python, you don't have to install anything, and this gives us access to threads. Whenever we create a thread, that's going to go to the operating system and it's going to ask the operating system to give us a new thread. And the operating system is going to be like, okay, here you go, new thread. You can run whatever you want in it. And what we're going to run is we're going to say thread 1 is thread. And the target is going to be our complex calculation. Notice that the target is the complex calculation function, not the result of it. So we're not going to run the function here. We're just going to pass it into the thread. And when we ask the thread to start, what it's going to do is it's going to start a new thread running just this complex calculation. And thread 2 is going to be a new thread where the target is the askUser function. Okay. So now we have 3 threads. A main thread, which is responsible for running through the app. A thread which is responsible for running the complex calculation. And another thread which is responsible for running the askUser function. So we're going to run these two at the same time, and we're going to see what happens, okay? So the first thing to do is to do time.time, measure the start time. Thread.start, thread 1.start, thread 2.start. Now, these threads have started, and they are running at the same time as our main thread. Okay, so now we have 3 threads running at the same time. When we start this one, the complex calculation function is running. When we start this one, the askUser function is running. And also our main thread, which is responsible for running this code, is also running. So we have to tell our main thread to wait for these 2 threads to finish. The way we do that, thread1.join and thread2.join. This tells our main thread to wait for thread 1 to finish and wait for thread 2 to finish. Again, these here are what we would call blocking operations because they're making this thread wait until something happens. But in this case, we want to do that because we want to wait until the thread's finished before we can calculate the end time of the thread. So we're going to say toThread total time is time.time minus start. Okay. This is fine. Don't worry about that yellow thing. Let's run this again and see what happens. What do you think is going to happen? Think about it before we continue. Ask me for my name, took a couple of seconds to do that, then it starts calculating. And in the end, it's going to take more or less the same amount as before, 8 seconds. Then it asks for my name again. It took a little bit longer now, just to type. But notice how, in total, it took 6.45 seconds instead of 8.36 seconds. But the complex calculation took essentially the same amount of time. The askUser took even longer. But this is fine, because in total, we took as long as the longest running function. And that is because the askUser function didn't do anything except wait. Okay? The difference between these 2 times is how much CPU the askUser function needed, plus how long it took us to switch between the threads in the CPU, in the processor, in your cores. As you can see, not a lot of it. In total, the 2-threaded time took more or less the same amount of time as your complex calculation, because your askUser function didn't actually need the CPU for anything. It just created a new string, and that's it. So hopefully this makes sense. This is what threads are for. It's for reducing waiting time. When you have a blocking operation, like this input, that is waiting making your program wait for something, that's a good use for a thread. If you have a function like this complex calculation, using a thread is not such a great idea. And here is a final example for you. In our threaded code, I'm going to not use the askUser function. I'm going to use the complex calculation function again. So now we'll have two threads, both running the complex calculation. Separate instances of it, but they're both going to calculate the same thing. Okay, let's run this again. It'll ask me my name first because that's the single threaded code. And now let's see what happens with our calculation. Remember, only one thread can run at a time. Okay, so you cannot run both at the same time, but we get started calculating twice because this is two functions that are running, each in one thread. And now let's see what happens. Notice how it's taking a while. There you have it. Complex calculation now took double the amount of time to run because they cannot run at the same time. So the operating system was sort of giving a little bit of time to one, then pulling it out and giving a little bit of time to the other, then pulling it out and going back to the first one, then going to the second one, and so forth, switching between the two. But all of them needed all that time in the CPU to calculate things. So in total, what you did is you spread out the time that each one was running, and you sort of interspersed one with the other continuously, and in the end it took double the time. If you had run these sequentially without threads, it would actually be faster because you wouldn't have to deal with removing one thread and putting another one in. So if you are doing things that require the CPU all the time, don't use threads. It's pointless in Python. There are other ways of doing similar things, as we will learn, and that could be better. Now we're going to go back to our askUser function here. Again, this code is available on the GitHub. Please download it, play around with it, run it, make a few changes, have a think. This stuff is complicated stuff, okay? There is a reason why not many courses go into this, because it's difficult. And I am expecting you guys to come to the course Q&A and ask questions, and, I'm here to help you out if anything is unclear. So please do use that resource. I want you to leave this course knowing about this stuff. So that's it for this video. Thanks for joining me in this one, and I'll see you on the next one.